Bright Tuty. Every student matters.
Okay, let us classify these numbers as rational or irrational. Now, this number is clearly irrational. Why? Because this is a rational number. If you subtract an irrational number from it, okay, there is no way this irrational part will be cancelled, right? There is no way in it. So, it will remain as it is. Other way of thinking about it is that the decimal expansion of root 5 is non-terminating and non-repeating. Okay, when you subtract it from 2, the decimal part, the part after the decimal will remain the same. Okay, so that will be non-terminating and non-repeating. So this number is irrational. Otherwise, it is the subtraction of rational minus irrational, rational minus irrational, and it will result into an irrational number. In this case, you see the irrational part can be cancelled. 3 plus root 23 minus root 23. So this irrational part is getting cancelled. Hence, I am left with only rational number. Okay. In this question also, irrational part can be cancelled. So this number is 2 by 7, hence rational. It is in P by Q form. Q is non-zero. Okay, and P and Q are integers. Okay, otherwise some of the students may argue with this also, 2 root 3 by 7, that it is P by Q form and Q is non-zero, hence this is also rational. No, P and Q should be integers, okay, and Q should be non-zero. 1 by root 2, it is clearly irrational. What we can do in 1 by root 2, we can always rationalize the denominator. How? By multiplying and dividing it by root 2. Now it will be root 2 by 2. Okay, we have rationalized the denominator, but irrationality is still there. Okay, so this number is irrational. Pi we know is irrational, so 2 pi will be irrational. When you multiply an irrational number with a rational number, it is not possible for it to cancel the irrational part. That is why the result will still be irrational. Okay. Simplify each of the following expressions. Now we just need to multiply these brackets, which is very simple. 2 into 3 is 6, 2 into root 3 is 2 root 3, 3 root 2, root 2 into root 3 is root 6. So this is the answer. Look at this one, a plus b, a minus b. So a square minus b square. This is 9, this is 3, so 6 is your answer. This is a plus b whole square. So the formula is a square plus 2ab plus b square. So this is 5, this is 2 root 10, this is 2. So 7 plus 2 root 10 is the answer. This is a minus b into a plus b, so a square minus b square, root 5 squared minus root 2 squared, that is 5 minus 2, 3 is the answer. Right, these were easier ones. Look at this question. Pi is defined as ratio of circumference of a circle to its diameter, that is pi is equal to c by d. But this seems to contradict the fact that pi is irrational. How will you resolve this contradiction? We know that we approximate value we take of pi is 22 by 7. When we divide circumference with diameter, we take approximate value. Now the key word is approximate. Right? This is not the exact value of pi. Okay. Pi is irrational because pi has got the decimal expansion as non-terminating, non-repeating. So if you think that 22 by 7 is its exact value, then you are wrong. It is the approximate value. Okay, so c pi equal to c by d is the approximate value of pi. It is not the exact value of pi. That is why this contradiction. Okay, because some of us think that this is the exact value. right? Now to remove this contradiction, we should keep this in our mind that this is not the exact value of pi, this is the approximate value that we take generally. Okay. Represent root 9.3 on the number line. So the step 1, take a line segment or draw a line segment AB of length 9.3 units. Okay, so I draw this line segment AB and this is of 9.3 units. Okay, now produce AB till C, okay, such that BC is 1 unit length. So I extend it till C and this is 1 unit. Okay. Third point, find midpoint of AB, find midpoint of AC geometrically. Okay. So you can find midpoint of AC, right? Let it be this point. Name it M. Okay. Now fourth point, draw a semicircle. Draw a semicircle taking M as center and AC as diameter. Once you do that, you will have a semicircle like this. Okay. Now in the fifth point, raise a perpendicular at this point B, okay, such that it meets the semicircle. Let it be point D. Okay. Draw perpendicular at B and it meets the semicircle at D. Now this length BD, the length BD is root 9.3. This length here is 9.3 root. Why is it so? We have proved it in the introduction part by taking length AB as x units and BC as 1 unit. So we proved that BD will be root x units. Similarly, in this case, it will be root 9.3. Now we need to draw it on the number line. So let it be the number line and this point B is, let us say, 0. Okay. So C will be 1 and you keep on extending it. So let it be 2, 3 and so on. Now you take a compass, okay, and draw an arc. So it will meet the number line at root 9.3. What I mean to say is, if you take this point B where we have drawn this length, this is root 9.3. Okay. This much we know by now, right? If we consider it as 0, the B point, then C will be 1, okay, and this is 2, this is 3 and this is 4, let us say. If you take this as 0 and draw an arc like this, so this point here will be root 9.3. Okay. I hope this concept is clear to you. The proof of this concept is in the introduction of this lecture. Okay. Rationalize the denominator of the following. So how do we rationalize the denominators? To make this irrational number root 7, what do I multiply it with so that it becomes rational, so that I can remove the square root sign? Obviously I need to multiply the denominator with root 7, and if I multiply the denominator with something, I will have to multiply the numerator with the same thing. So this will give me root 7 by 7. This is the answer. In this case, I will make use of this formula, a square minus b square equal to a plus b into a minus b. So the denominator is root 7 minus root 6. So I will multiply it with root 7 plus root 6 and I will have to multiply the numerator with the same thing. Okay, because this is the same number as this one. So this will give me root 7 plus root 6 in the numerator, and the denominator will be a square, that is 7, minus b square, that is 6. So the number is root 7 plus root 6. Similarly, I can rationalize this like this. Okay, the numerator is root 5 minus root 2, and the denominator is a square, that is 5, minus b square, that is 2. So it is, okay. The purpose of this rationalization is to remove the radical sign, this sign, from the denominator, which we have done. Okay. Similarly, this one, to rationalize this part 4, what we can do is we can multiply and divide it by root 7 plus 2. Now what will happen is, the numerator is root 7 plus 2, and the denominator a square, that is 7, minus b square, that is 4. So you will have root 7 plus 2 by 3 as your answer. Okay, so this was about rationalization of these numbers. I hope you have understood this exercise. Okay, so because in this exercise we found numbers like root 3.5 on the number line, right? We proved it using x units, we proved it using general example. Okay, other thing was in this exercise was the rationalize of denominator. The other thing that we studied in this exercise was rationalizing of denominators, right? By rationalizing the denominator, I mean that we need to remove the radical sign from the denominator, right? So these were the concepts that we discussed in this exercise. I hope this exercise is clear to you. Thank you.